So we're very pleased to be with you tonight. We're going to be talking about how we are using artificial intelligence at Osprey Informatics for industrial monitoring. Next slide. Okay, so I'm Rosalie Gordon. I'm the Director of Product at Osprey, and this is my colleague Dave Woods. He's the Director of Development. And I have about a decade of experience in product management in small and large companies, also experience in engineering and supply chain. I also happen to run a meetup myself, the Calgary Product Managers Meetup. So you can come and check that out next Thursday if you're interested in that. And one other thing I should say is my job at Osprey, this is the first time I've worked with an artificial intelligence product. So we have some interesting kind of perspectives and learnings to share from you, maybe like from people doing this for the first time.
All right, so yeah, hi, I'm Dave. This is also first time I've worked in a company where we use machine learning really at all, so it's kind of exciting for me. I've been doing software in Calgary for a long time and worked for lots of different companies based in different places. Apologize for bringing the management layer out tonight. My data science team, I would have brought him, but he lives in Whitehorse, so it's not always easy to get him involved in this. Yeah, hopefully we can tell you some interesting things.
All right, so here's what we're going to cover tonight. We're going to give you a little bit of information about Osprey, what we do, and then focus on our AI-powered alerts, which were a greatly improved alerting system that we implemented using computer vision. And then we'll end by talking about what is our vision for AI at Osprey going forward. So let's start with Osprey. Our customers are companies, industrial companies that have remote and distributed sites, and they have a problem. Their problem is they need to reduce operational costs, and quite significantly, quite seriously, this is their big challenge. At the same time, they are expected to mitigate risks in the area of health, safety, and environment. This is a large market. It's a $1 million addressable market in Canadian oil and gas alone, and our product is applicable beyond oil and gas to other industry verticals with remote assets such as mining, forestry, and agriculture. So here's our solution. It's an end-to-end IoT product. This is a visual monitoring platform for remote sites. And I'm going to walk you through this diagram from left to right. So on the left, what we have is cameras, video cameras, nothing special, off-the-shelf video cameras that are installed at remote sites across Western Canada. And in some cases, we also have something called a Cloud Bridge installed, and this is our edge device. It's a local computer installed on site that's used for storage and in the future, maybe some analytics. So images are captured on site and transmitted over the cellular network to the cloud. Now, we do not want to be transferring HD video over cellular network because that would be very expensive. So what we do is we use video analytics built into the cameras to capture an image when something moves. Or there's a few other rules we can set up for when images are captured. And instead of sending video, we're sending images only, by exception, to the cloud. So on the capture side, then, we can efficiently manage all these IoT devices, these cameras, and also other kinds of sensors. You see there is a picture of a drone there. We're looking at using mobile cameras as well. So what happens when these images get to the cloud? This is where we've started to do our computer vision. So, and our vision is that this is one of the places where the computer vision will happen. And we're using computer vision to detect items of interest or activity of interest, taking all this visual, big data, unstructured data, and turning it into useful information that people can use to make decisions. And then on the right is deliver, and that's where we deliver this important information to all sorts of different users throughout the enterprise. So it could be people in head office, it could be people in the field, it could be operators, it could be safety people. Everyone needs information, but they need different information for different purposes. So this is personalized, exception-based reporting for just what you need to do your job. And we also integrate with other kinds of sensors and enterprise data systems down here. Okay. So there's many use cases, as you can imagine, for a visual platform like this. And here's a few I can talk about. So the first one is productivity, reducing, cutting routine site visits, and prioritizing the site visits that you do based on being able to do a visual inspection ahead of time. So our customers are making 50% fewer site visits because they can inspect online. Second is health, safety, and environment. So this picture shows a FLIR thermal camera monitoring for methane emissions on a tank. And so we're not just using optical cameras, but IR cameras, and we can alert based on that so that they can detect the emission and also estimate the size of it in terms of for reporting and paying penalties. And then the third use case, maybe the most obvious when you think these are cameras, is security and supervision. So a lot of times our product is used to monitor for the movement of people and vehicles coming and going from site, either monitoring that people who were supposed to be there are there, like the contractor, did they show up for the amount of time they said they were there on their invoice, or detecting crimes in progress. And I'm proud to say there are people in jail right now because of our system detecting, there is a lot of theft happening of batteries, copper, anything. It's amazing what people will take. So, and this last use case is where we've started to apply computer vision. So this is the one you'll hear us talk about the most for the rest of the presentation. And here's our customers. So the major oil and gas companies in Western Canada. And we also have a number of industry collaborators. And possibly what is most interesting to this group is this one right here, SWIRI, Southwest Research Institute out of Texas, is developing some really interesting computer vision, particularly around leak detection, and we are partnering with them. Okay, I think this is where I pass it.
All right, so the first place where we're taking machine learning into account is with active alerts, AI-powered alerts feature, I guess, if you want to call it that. And I'll describe to you what we did and how it made our product a lot better. Sam, if you're familiar with video cameras at all, like really cheap ones don't have a lot of features, but any sort of industrial or commercial scale IP camera has either in it or associated with it motion detection module, so which can be pretty fancy. Like you can very simply detect movement, it can detect movement across a line, it can detect movement with the cadence. This is not machine learning, this is not a computer vision algorithm, this stuff's been around for a while. In some cases it's being enhanced that way, but it's otherwise pretty basic. You can tell when you're standing still. If you guys ever been in the airport where it says don't stand in this area or an alarm will go off, that's these cameras. They have a dwell, and they can tell if you stay inside a box, not just if you move outside of it, right? And that's all well and good, but on site what we found, and this is pretty typical when people try to use these things, is that motion detection detects motion, and so that includes animals and trees going in the wind and weather. Like we can actually tell, even with the enhancements we've made in our product, because we run our own APN, like a virtual cellular network to connect all these remote sites. When it snows, our data costs go up a little bit because snow causes cameras to think there's activity and so forth, and you can actually see it creep up, right? So we want to kind of eliminate stuff like that. One of the other things that you get is on these industrial sites, again, often the cameras are located next to something that vibrates, and so you can get motion detection when nothing is moving except the camera, up and down, right? So it'll tell you. So what we did to get rid of the spam was we introduced machine learning. So get to the next. Not a very fancy slide. But the idea is labeled as activity or however, however it determines that a frame is of interest. And these are all video cameras, but like Rosalie said, we work almost entirely with images to the extent that we can. Otherwise, the cost would become very prohibitive. We do capture video, and if a customer needs it, we get it for them, but that's exception-based. Anyway, so what we did was we wanted to introduce smarter detection, so that would be computer vision, machine learning, to pick out, so we know that an image has an event and it has action, but what is it? Is it a train? Is it a person? What can we detect and what level of confidence do we want to use? And so when we actually put that into place, we got a huge improvement. People were getting spam to the point where in some cases it wasn't a useful product to them because they'd get told about all this motion, all this activity, and you guys, every single person here gets alerted on something, right? Like on their phone, and if it's too much, you're just going to start to ignore it. So we were able to make a huge improvement by using CV tagging. Go to the next slide. This is just what the product looks like. There's that little live thing up there. So what we can actually do is give people real-time information when a truck drives onto their site, or when it moves off the site, or when a person comes, and we can be very specific. There was a site we did recently where the only really thing they really cared about was when the train comes, because trains come at all hours. They have no good schedules. CP Rail, I don't know. Anyone here work for CP? But anyway, that's all they wanted to know. So we set it up to use the computer vision to, with a certain level of confidence, if you saw a train coming down the track, know where to use it. So it can be done in real time. There's nothing super complex about what we're doing, but it changed the product a lot. And if you go to the next slide, these numbers are hard to read, but it says like the top line is something like 7,000 event reports, and when we started using computer vision, it went down to under 2,000. It made a huge difference to most of our customers, and Rosalie has cool quotes on here about how awesome we became and how much our customers like us better, which is completely true. So that was our first taste of actually taking things and doing machine learning to help us out. And the actual machine learning part is something that we'll get into a little bit next. And Rosalie's going to do this one. So there's lots of challenges that we encountered, and I'll tell you about them.
All right, so when Drew asked me to talk, he said, keep it real. We don't want the shiny sales presentation. We want to know, the whole story. So we have a couple slides to tell you about the challenges that we encountered when we were implementing a computer vision feature for the first time. So the first thing I noticed when I came to Osprey is this need for massive training data sets. And that's not so bad because we have 800 cameras in the field collecting full video all the time. We've got a lot of data, but because we're doing supervised learning, all that data, how do you actually label the amount of data you're going to need for training so that your training is useful? And we quickly found out that asking developers to do that job is not a good idea. So after all the developers left, and we went, oh, okay, that actually is not a good idea. So then we came up with a better solution, and we actually automated a process to send images to Mechanical Turk and have Mechanical Turkers drop bounding boxes and label the data and send it back, and that all works. And so we have something that we built called the CV Toolkit for actually pulling data from our system, sending it to Mechanical Turk, getting it labeled, and then using those images for training and testing our CV. Then there's the explainability problem, and I guess I can describe that best with kind of a story. And I've been working in tech for a long time, and what I found is, from my experience, is if you find a bug, and if you can replicate it and figure out how it should be replicated, and if you bring that to your most senior technical person, they can almost always fix the bug. 99.9% of the time they can fix it, and they can fix it pretty fast. And so this is what I'm used to. And so when the classifier classifies a tree as a person, I take it, here it is, and we can, there it is right in front of you. And the technical person says, yeah, I see that, and we don't really know, right? We don't really know how the computer made that decision. And that was a new experience, and that was a new experience for our executive, to have the, people, the technical people kind of shrug their shoulders and say, the computer does what the computer does, and we can try retraining, but, we're not sure the results we're going to get, or if that will happen again or not. So just a different mindset, and we had to get used to that. Generalized ability of learning was a challenge. So we quickly learned that if you have a training set that was taken on a sunny day, that's not going to help you much when it snows, or different lighting conditions, or different seasons, that we have to have this robust training set that covers all possible scenarios for it to be useful, because it doesn't generalize. That also means that the off-the-shelf classifiers don't always work that well for us. So for people and vehicles, a lot of the off-the-shelf classifiers are trained on consumer data, like what people upload to Google Photos, and so people look like people on the street. And at our sites, people wear hard hats and PPE and boots, and the transport trucks are tanker trucks, and so vehicles are very different as well. So we can't always use the algorithms right out of the box. And then bias in data and algorithms is always an issue with computer vision. Not as much of a problem for us just because of the use cases that we're dealing with.
Even more problems, although we do have some solutions, not just asking for help. The other thing that Rosa mentioned about, out-of-the-box pre-trained classifiers and the very standard data sets that are sort of everyday use. A lot of our cameras are up from an above and three-quarter perspective on the scenes, because on a remote industrial scene, you might not get a lot of choices where you put your camera, so it suddenly changes things. Our classifier likes to think that a lot of trucks are boats or trains because of the angle. Catwalks are all ships for some reason. It's just, and we have the ability to sort out and train these things, but it is a challenge. So a couple of the other things, from a development standpoint, because I'm still pretty new to this, you guys all know that the pace of change in machine learning AI is crazy. And so, we went through this bit of a journey before even I started at Osprey. We had some really good people, some PhDs from U of A, and people that knew what they were doing with neural networks, and they were writing background classification algorithms, and we were doing some very low-level stuff 3 years ago. Almost all from scratch, very little stuff out of the box. But we're a small company, and we have other focuses, and our ability to bring in all those people and to compete at that sort of pace of development really didn't make a lot of sense. So at the end of the day, after doing a lot of work, for basic visual classification, we ended up switching, and it was a difficult decision because we felt like this was our juice, but it really wasn't, right? So we used the DarkNet framework and the pre-trained YOLO, if you guys have ever used that. It's a visual. It's not really a classifier because it only looks once, but it's a tagger, and that was what we did. So we picked that. And then that was great, but we had to do what Rosalie said. We did write our CV toolkit that sends the images to Mechanical Turk, and we get people to basically vote on them by tagging them. And then they email you and complain that they didn't get 3 cents because, I swear, and then you have to write back to them and tell them that, no, they missed the truck. Anyway, it's useful. And when we did that, though, I think there's a lot of actually tools kits that do that now, but we didn't know that at the time. So we did it all ourselves, wrote this toolkit. And it does a lot of statistical analysis. It gives us precision and recall for different sites and different conditions, different customers and things like that. And it was cool, and it works, and we're glad that we did it a year ago. But I'm sure you all are completely aware that Google, Amazon, Microsoft, Image Tools, the SageMaker, and everything, it does all that for you. These tools are not super developed. They're pretty new in some cases. But SageMaker does a lot of things. Not around the data science part, but around the tooling that you need, right? So you'd have to be crazy, it seems like, going forward to write your own tooling. So again, the rug gets pulled out from under you, and we still use some of the tools we have, but one of my guys, we ported we were running YOLO ourselves, and we ported to SageMaker in 6 hours the other day, and now we don't have to run it anymore, and it'll handle some of the training and tagging stuff for us, right? So that's that was one of the challenges, is just a small company. We're really about, if there's any advantage for us in this field, it's learning how to use the tools and the techniques that probably some of you guys are developing, right? So that's the big thing for us. And the other big challenge on the development side, this is more of a software dev thing. If there's any UX people, this is probably not a UX crowd, but if there is anybody here, managing things for the end user is really fascinating because for most people, they have different use cases. If you're a security guy, false positives are okay. If you're an operations guy, they're not typically. So if you're using the same classifier, you have to optimize it locally. It can be difficult. And we've had discussions about exposing some of the factors that you could do to the end user, and we keep shaking our heads. Like, you could give people a confidence slider, but they don't understand, and you wouldn't want them to. Like, it's a bad experience to give them, I believe, to give them the tools to try to tweak their own results from essentially image classification. And even if you give them the ability to say, well, just let them tell you if the image was good or bad, right? They won't tag that. Nobody's going to hit that button. Nobody, right? Well, not nobody. There's always the guy who will. But most people are never going to do it. So, giving people control over what machine learning returns to them versus keeping it simple is a struggle that we have. And I don't know what the right answer. I keep thinking we could just expose this or that, but it doesn't really make sense. They want the tag and they want it to be right. So what you need to do is behind the scenes train, and in some cases, the interesting thing is, we were talking before about global maximization and the ability to do it. We don't see that we could do that with the way our system is set up at all, because the use cases vary for the same process pipeline. So if anyone knows what the right answer is, please come talk to me afterwards and let me know. And vision for CV. So things we're doing going forward. Some interesting things we're doing. You probably noticed, if we said in our diagram, that we actually pull images into the cloud before we tag them. That is not a great solution, especially for us. We want to filter stuff out at the edge. So we're looking at pushing CV to the edge, which seems to be a trend in the industry in general. The phones now have more custom chips to help people do that, and things like Siri and those voice-activated assistants, they want to do more processing locally, which saves the company money, of course, in all cases. But there is a cost, and for a small company like us, we're pretty good at running a big fleet of IoT devices in the field, but if we add more complexity to them, it increases the cost, right? So we're looking at doing the cost saving of putting things locally on the edge. And the other thing we're looking at is implementing more niche classifiers. For a company like us, we think that very specific, there's one of the cases we keep coming up, there's a guy that wanted to know if vents would open and close, and that was all he wanted. And you could use probably a general vision classifier to do that, but if you have enough images, you might as well just train something super precise for that, right? Because it's going to tell you if the vents open or close. So we're trying to figure out how niche we want to go to solve these problems, right? Because it's getting easier to train things. You need less data with the tools that you have. So we're looking at, one of the questions we have is to what level we would apply a particular trained algorithm. We don't know for sure, but that's one of the things we're looking at. So what do we got on the next one? Rosie, finish it off.
Okay.
All right.
All right, so given all we've tried and learned over the last 3 years, the way we see ourselves now is we are the visual intelligence platform for the industrial IoT. We are not going to be the CV specialists, the ones that are developing the algorithms. We want to be the platform where you can plug and play different CV algorithms depending on what solution you're looking for, what problem you're trying to solve, what you are trying to detect for your specific use case. So we see ourselves as the platform to pull in all these different third-party CV algorithms. And this is just a picture of some of those that we're doing now and some that are possible for the future. So on the bottom here, vehicle and people detection is what we've just implemented. And that's how we're getting the great results for our alerting system. And above, equipment status, that's showing detecting whether a pump is pumping or stopped. And we're doing a little bit of that. License plates, we have implemented on a trial basis. And if we decide to really pursue the security use case, we can drop that kind of analytic in. And then these top two here, gas leaks and oil leaks, this is what we're working on with SWIRI. And they have some really interesting computer vision to detect gas leaks with an infrared camera. And oil leaks, this one, you can see the different colors. They're not just identifying is there a leak or not, but they can actually tell you what liquid it is and color code it. So that's really interesting. And then all sorts of things for the future. So here's an example of corrosion. We know that that our customers do a lot of visual inspection for corrosion, and other use cases keep coming up. The vent open or closed, or all different kinds of. Basically, anywhere you would have a person visually inspecting, and especially where it's going to be dangerous or costly to do that with a person.